Welcome to the Learning Rust by the Book series. And today we are going to do chapter 2 of the official Rust book, which is writing a guessing game. So in the previous chapter, we have installed Rust, Cargo Watch, and Rust Analyzer, an extension of VS Code. So we are all ready to go. So let's do a cargo new guessing game that creates a folder of guessing game. And now we're going to create the VS Code workspace by doing code and the name of the folder. You can also do an open workspace in VS Code if you don't have the command line installed. Now we have our VS Code. We see our cargo to ML with our package information and no dependencies for now. And then in the source folder, we have our main.rs, which is a main file with our main function, which print hello world. We're going to toggle the terminal of VS Code, and we're going to type cargo run, and everything works. Now we're going to do our cargo watch, such as every time we save the file, it will rebuild and rerun the file. So that will allow us to do very fast development here. So we're going to do cargo watch -q for quiet, -c to clear the terminal at each run, -x to run a cargo command, and we're going to run the command run. Okay, now we get our hello world, and if we edit, press save, everything gets rebuilt and rerun. So everything is set up. So now we're going to replace here the println with our plan, with Rust comments. We'll talk about it later. And then the last little trick here that we're going to do, that we did in the previous chapter, is to add our crate attribute to turn off unused warnings. So those are very useful warnings when you do production code, but when we are learning, it's good to turn them off, such as we can tune down the noise and just focus on the errors. And then at the end, usually you will comment out this line with // at the beginning, such as you can clean up your code. Okay, so now let's zoom into the code here. So here's the plan. The first is we're going to generate the secret number. Second, we're going to ask the user a number. Third, we're going to read the user number from the input from the terminal. Fourth, we're going to verify the user number and tell the user if he has won or lost. Fifth, we're going to take 3 and 4 and we're going to put in a loop, such as we keep trying until the user finds the right number. And then sixth, we're going to print a goodbye message. So here's what we have seen here is how we do comments in Rust. You just do a // and everything after will be ignored by the Rust compilers. VS Code will put them in green, such as you can see when you have comments. And you can put it in the beginning of a new line or after some codes, as we have seen before with a crate attribute. Okay, so first we're going to generate our secret number. And actually for now, we're going to hardcode it, which means that we're going to give a fixed value. So let's create our secret here, our variable. So it's going to be let to create a variable. Secret, that will be the name of our variable. And then we do equal, and we're going to give a value of 22. The first thing that we see here is that we have this colon I32 that we didn't type. What happened here is that Rust infers type. So when we type 22, Rust by default will infer that the type is I32. That is the default in Rust. And Rust Analyzer, which is a plugin, is displaying that into VS Code. If you want to turn this off, you can do a command comma to go to the settings, you type inlay in the search box, and then you uncheck the box. So now about this type, we could have typed it explicitly. That would have been exactly the same in this case. So what are those types? In Rust, like many compiled languages, like Java, Go, C++, and C, you have many integer types. And this is to save space in memory. So in short here, the more bits you have, the more memory it will take in the memory, but the bigger number you can have. And then the integer type are split into two categories. The signed types that start with I, and they can contain negative and positive numbers. And then the unsigned types, which start with U, and can contain only positive numbers. So they can have bigger numbers for the same number of bits, but they cannot have negative numbers. And the last row here, iSize and uSize, are dependent on the device architecture. So on the 64 bits, uSize will be U64, and on a 32-bit computer, use size will be U32. And by default, Rust default to I32. And here we could have entered I64 and it would have worked exactly the same in this case. So now let's go back to the default here, the I32, and let's talk about the second type of numbers that are the floating points, the decimal numbers. And you have two types, the F32 and the F64. And Rust will default to F64. So here if we do a .0, the infer type is F64. And if you really need to save some space, you can make it F32. But for our game here, let's go back to integer, because otherwise it will be a very hard game to play. Let's do a quick recap here about variables and mutability. So in Rust here, the default is that every variables are immutable, meaning they are locked. So for example here, if we wanted to change the value of secret here by, for example, 44, we press save and we get this error. Cannot assign twice to immutable variable. So what we will need to do in this case is add the keyword mute to make it mutable, and that will unlock the variable, and we press save, and that will work. Now obviously in this game, we don't need to have it mutable, so we're going to remove it and leave it as is. So now we're going to ask the user to give us the number. So first we're going to do a println, the macro, guess the number, press save, and then we see the result. And in fact, here to ease development, we are going to print the number as well, such as we can test if our code works. So in this case here, we're going to put hint, and we are going to put the braces to format the string, and that needs to have the matching argument on the right side here, which will be secret, which the braces will be replaced by. We press save, and now we get our guess the number, hint 22. So now what we're going to do here for the third step is to read the input from the user. And to do that here, we need a mutable variable, such as we can hold the value of the user, which we don't know obviously at compile time. So for that, we're going to create a variable here with let, and it has to be mutable, so mute. We're going to give it a name, which is guess. And then we're going to create a new object here of type string. And so that is the way we create a new object of string. So here we have the type, which is string. And then to access the functions of a type, you use colon. To access the functions of an object, you use a single dot. So we'll see that later. So now, here guess has a mutable empty string that can grow. So now we need to read the input from the terminal. To do that, we're going to use the IO module, which belongs to the standard module, std. So the way in Rust that you import a module is with the keyword use. In other languages, could be import. So here we use std for standard library, and then the way that we navigate down to the submodules is with a colon. So std IO. So now the submodule IO is part of the scope of this program. So this is how we tell the compiler to say for this program, we need to have these modules. And now is a good time to talk about Rust naming convention, because that will help a lot to understand the code and the libraries that we are using. So there's two main conventions in Rust. There's a snake case and a camel case. The snake case is everything lowercase, and when there's a multiple words, you put an underscore in it. And so for items like modules, functions, macros, variables, arguments, all of those are lowercase. And then if you have multiple words, you separate the words with an underscore. And then you have the camel case for object types kind of items. We don't have to worry too much about the specific, but the good thing to know here is that if you have an uppercase, you know that you have a kind of object type. And if you have lowercase, it's either modules or an argument or a function. So now with that in mind, let's go and add our code to read the input from the terminal. And that is these three scary lines. And do not worry, we're going to go one by one. In the first line, we're calling a function stdin, it's lowercase, which belongs to the module that we just imported above IO. And so again, to navigate down the module, we use the colon. So we do IO stdin. Rust Analyzer tells us that it's returning a stdin with uppercase S. So now we know that this is a type of an object, and the way to access functions or properties of an object is like in many other languages, is with a dot. And you can put it in a new line if you want to. So now we have a dot here, and we're going to call a function, which has a snake case, readLine, and we are going to give the mutable reference of our mutable variable guess. And here we do not want to give the guess variable directly because we want the guess to be owned by the main function. So we do not want to transfer ownership to the readLine, as we have seen in the first chapter. And what the readLine returns here is a result object type, which is actually an enum, with two subtypes here that we can see these little brackets, which is the usize and the error. And that is a way in Rust that you handle errors. If you have a function that might fail, rather to return the result, like usize, you will return a result enum that might have the result of the OK method, if everything goes fine, or the error of the method. And then in Rust, because this result is an object type, it has a function expect, which if it returns the result and everything is okay, expect will do nothing, just return the value. And if it's not, if there is an error, then it will panic, which means stop the program and then print this message. So obviously here we could actually handle the error, but in our case here, we can just fail it right away. And that's it. It's quite a bit, but don't worry if you don't understand everything yet, because the more you use Rust, the more these things will become natural. It's actually very well thought out, so it's very worthwhile to learn them well. So now we can press save, and we can enter number. Now nothing is done because actually the program finishes, so it doesn't crash, but it doesn't do anything. So the next things here, in number 4, we're going to add our println, and we're going to format a string with the braces again, and we're going to add the argument here, guess, which is now, at this level here, the stdin and readLine will have put the value of the user in it. Now if we press save, we enter a number, and then it prints the number back. So now if we enter a number again here, nothing happened because again, the program just finished. So this is just cargo watch kind of things. One of the great ways to learn a new language is once you have your working code, try to break it to validate your understanding. It looks a little bit weird, but it works very well. So for example here, what happens if we remove the keyword mute? Press save, and then we get this error. And this error says you cannot have a mutable reference on a variable that is not mutable. So far so good. So let's go back. And now what happens if in the readLine function, we just pass a reference of guess and not a mutable reference? We press save, and we get this error that say, well, readLine expect to have a mutable reference, and you are just giving a reference which is not mutable. So you get this error. What is happening here as well is the code got reformatted by Rust code formatter. It's actually a very good one, so I will recommend here to get used to it and just follow the default formattings as much as possible. What happens now if we remove the reference to guess? We just give the guess variable, which basically will move the ownership. It's not what we want, but just a test. And here it says that readLine only wants a mutable reference of a string, doesn't want to have the ownership. And this is very good because we don't want the readLine to take the ownership because otherwise, what's the point? We want to get the value that the user has put in. And readLine say, I don't want ownership. I shouldn't be responsible of deleting this data. I'm just adding to it. So now we go back here and we're going to put our @muteref, press save. The Rust formatter kind of reformat the code, and we have everything that works. Okay, so now what we need to do is to compare the string value to the number secret. And to do that, we need to parse the string from the user into a number to be able to compare it. So we're going to create a variable, guess_number, and then we're going to have an explicit type here, i32. And this is important in this case, we'll explain why later. And then we have our variable, guess, and inside the variable, which is a type string, there's a function, a method, which is called trim, which will remove the white space at the beginning and the white space at the end, such as if the user press space space, everything will work fine. And then the function stream is returning a slice of guess, so actually there's no copy going on. And the slice of string has the same method of strings, so it has a method parse. So we're going to parse it to whatever the type is expected. So here's I32. And so this is why it was important to be explicit to tell Rust to what we want to parse the string to. And then the parse method will return a result enum similar to what we had above, with either the I32 result for guess number or the error. So we're going to use the same techniques that we did before. If there's an error, we want the program to stop. And so we do that by calling the method expect, and then we give the message that we want to display when the program stops. So now we can update the println here with the guess number, press save, enter a number, and then everything works fine. Now if we want to test what happened if we enter an invalid number, so we press save, and we enter 22AA, press enter, and we get our panic message. So obviously, as you write your program, you want to handle these errors, such as, for example, here, you can ask again the user to enter a valid number. And obviously, there's much more into the error handling, but we'll learn about it in future episodes. Okay, so here's a little trick here. On the first kind of IO stdin, we had this multi-line which was formatted, and so we saw all of the output. But because the get stream is relatively short, the Rust formatter didn't break the line, and we didn't see these little hints here. So what you can do here is mouse over every part, and you will see a quick little documentation for each one, which is very convenient. The other trick here with Rust Analyzer is without pressing save, you can break the line, and quickly you can see what it returns. And then you press save, and then it will reformat, and everything is good to go. There is one more thing that we can do here in Rust to clean up our code, and that is variable shadowing. In our case here, once we parse the guess string into a number, we do not care about the string value anymore. We just care about the new value, which is a guess number. So what Rust allows us to do is to redefine a new variable with the same name that was used before. And then after it's defined, the previous one is not available anymore to access because the new name is a new variable. So here in our case, rather to have guess underscore number, we just have let guess of type I32, and then it's going to be equal. And then on the right side for this line, it will still be the old value here above, so we can still do our parse. But then after, when that is done, on the next line here on the println, the guess variable, as we can see here, is in blue and not in pink anymore. This means that this variable is actually now the new variable that has been defined, which is immutable, which is the I32. And that allows your Rust code to not have too many variable name variants when it's not really needed. It might look a little bit weird here, but it's actually very well thought out once again. Important to note here, this has nothing to do with mutability or type or anything. You are just shadowing a previous variable. So now we can press save, enter a number, and it works exactly the same as before. Okay, so now we can implement our if-else logic for the win-lose. So first we're going to do if guess equal secret, println you win, and then in the else, we do println you lose. So in Rust here, you don't have to put the braces around the condition, the guess equal secret of an if statement. And if you do, you will get a warning. So it's better to stay idiomatic to Rust. So now we can start playing. Press save to start. 11, you lose. Press save to restart. 22, you win. So for now, it's a one-shot game. It's not really fun. So what we need here is to put 3 and 4 within a loop. And in Rust, there's 3 ways of doing loop. There's the keyword loop, the keyword while, and the keyword for. And today we're going to see the keyword loop. So here we just take our code block, here 3 and 4, and we're putting into a code block with loop. We press save, and then we can start playing. Then obviously, it continues to play no matter what, because there is no breaking point. So what we want here is to end the loop once we win. So for that, we go to our win block here, and we're just going to add break. Then we're going to rename here the println when we lose, try again. And then finally, to make sure that we know when we get out of the loop, we're going to print a little message here at the end, goodbye. And we're going to use the special character /n to do a little bit of formatting. So /n is a special character in a string that will do a new line. So like this, the goodbye will stand out. Now we press save, and now 33, try again, 11, try again, 22, you win, goodbye. So far so good. So that is pretty good, but it's not really a fun game because it can be very long and there's no real challenges here. What we really want in a guessing game is to say if you are too low or too high. And for that, we need to compare the number guess with the secret. So we could do that with if and else if, like other programming languages, and that is definitely a valid option in some cases. But in Rust here, there's a very productive way of doing these kind of things, and that is using the match keywords. So many functions are returning enums that then can be matched. So here we're going to see how it works. So first we're going to go on the top of the file, and then we're going to import an enum, which is part of the CMP for compare submodule of standard libraries. We press save, everything works. Then we go down to our code, and we're going to replace this if-else block by a match block. And it looks a little bit scary, but once you get used to it, it's very, very, very efficient. So let's go line by line. So first here, we have a new keyword, which is match. So what match does here is that it expects that the expression on the right of match before the braces is going to return an enum. And in this case here, the enum that it's expecting, and I'm simplifying it here a little bit, it's an enum ordering, which has 3 enum variants, which is less, equal, and greater. And here the CMP method, which is for compare, of the type integer, will compare the number and will return an ordering enum with one of these 3 values. And in the match code block, we have what is called arms, which starts with the value of the variant. And then on the right side of the arrow, we have the code to be executed if the enum match this specific variant. So here, for example, if we match less, we're going to print too small. If we match greater, we're going to print too big. And then if we match equal, we can give a code block because we have more than one macro or function to call. And then we're going to do the println and then call the break to stop the loop as before. So now let's save and let's see if it works. 333, too big. 11, too small. 22, we win. And that's it. We did our first match in Rust. And matches in Rust can get very powerful. So it's very worthwhile again to learn this concept very well because it can make your code scale very well. Okay, so the last step here is to make our secret a random number. Right now it's hard-coded at 22, so not very challenging. So first we are going to stop the cargo watch. So you click on the terminal and you are going to type Ctrl-C on your keyboards. That is important when we install new libraries. Then we go to the website, crates.io, and that is where there's all of the open source libraries for Rust. We are going to type rand, and then in the rand package here, we are going to mouse over the version number to copy the version number into the clipboard. Then after we can go back to our code, we are going to open cargo2ml, and we're going to paste the values that we had in the clipboard below the dependencies. And so now here we see that we are using the external crate, the external library, rand, at the version 0.8.3. So now we can do a cargo build and cargo watch to start again. And we go back to the source and we zoom back into main. Now at the top here, we need to use this library. The same way that we are using standard libraries, we are going to use the use keyword. So we are going to type use rand, and then within the rand modules, there's our ing type. Once we have done that, the rand modules is inside our application now, so we can use it in our code, and we are going to change the 22 by this line. So here again, we are using the rand module inside the run module, there is a function, which is thread underscore RNG. And this function creates the context here to create the random number. And then it returns an object that has a function that has a gen underscore range that generate a random number based on a range. And a range is a Rust construct in the language that allows us to define a start and an end of an unsigned number with a notation ... On the left side, you define where you want to start, and on the right side of the ... you define where you want to stop, +1. So for example, here we are saying we want to start at 1, ... 101, which means that it will create a range from 1 to 100. So here are some examples. If we just don't put anything on the left and the right of the ... that will go from 0 to the maximum number. If we have ... 3, that means that we have 0, 1, and 2. And again, the 3 is excluded. If we want to include 3, and we don't want to add 1, we can do ... equal. And then the last number become inclusive. And then if we want to start from a specific number, we can put it on the left of the ... and it will start from the number. So the left side is inclusive, and the right side is exclusive by default. And the great news about that is it's very efficient, so it doesn't create an array, and all of the APIs can iterate through that. So now we can press save, and now the hint here is 12. So if we hit 12, then we win. We press save again to restart the game. Now it's 51, so we're going to test the other logic. So we do 1, too small, 66, too big, 51, we win. And that's it. This is our first command line Rust game with very few lines of code. And while there is quite a bit of new concepts to learn, the great news is the more you learn about Rust, the more productive you will be. And your code will be robust, safe, and efficient. Okay, that will be it for today. If you like this episode, feel free to add a like, always appreciated. In the next episode, we'll do the chapter 3 of the official book, and we'll talk about variables, mutability, data types, functions, and control flow. Until then, have a good one.